Okay, now I want to talk about triangulation in the mean triangulation and in triangulation on comparing two triangulation and understanding which one is better using vectors using vectors of angles or angles vectors. So let's try and define what is a vector angle of a triangle of triangulation. So here it is. Here I have I don't know, a polygon, and I want to triangulate it. I have two options. One option is triangulate with this one. The other option is to triangulate with that one. Namely, we have two different triangulations. Now let's look at the two different options. If I look at the first option, I have this again polygon which I triangulate like this. Let's look at the angles of this triangulation. So I have here 60 degrees, I have here 60 degrees, 40 degrees, here 100 degrees, and here 60, and here 40. Okay, so I can define a vector of angles for this triangulation, which will be called a of let's call it t. So t, this is the vector of angles, and I will order it in lexicographic order, starting with the lowest angle and continuing in an order, lexicograph order, to the biggest one. So we start with the smallest one, which is 40. We have 2 times 40 here, 40 again, so here it is. So 40 degrees. Then we have 60 3 times, so 60 60, and then the last one will be the 100. So this is the angles vector of this triangulation. Now let's look at the other option using this line, and we will understand which triangulation is considered better. And the triangulation that will be better is the triangulation with the bigger angles based on the lexicographic order. So let's look at the other triangulation option. We said that there is another option which is triangulating using this line. Now you can understand that this triangulation is the better one. The reason this one is the worst, the very obvious explanation is if you're looking at this point. If you're looking at this point, this is obvious that this point is more likely to be closer to this one and that one compared to this one and that one, which are more far away. But if I use this triangulation, I will consider this point in relation to more far away points, which are less likely to be the true points which connect them. Namely, if I'm looking on this map as a height map that defines the height of the points of, I don't know, geographic map, so this point is more likely to be closer to this point. So I need to triangulate like this, because if this is 200 feet and this is 700 feet and this is, I don't know, 10 feet and this is 20 feet, probably this point is more likely to be, because it's closer to this point, more likely to be more common as this point. Since if I look at this triangulation, I will, for example, say that this point is the average between this one and this one, and if I will use this triangulation, I will say that this point is the average between this one and that one, which is more likely to be true because they are closer. Maybe I should have done it even more obvious using triangles like this. So this is, oh, maybe even more like this. And of course, this point is more probably closer to this and this, and less likely closer to this faraway points. So you can understand that I want a triangulation which will connect points that are more closer together. And if you look closer at this, look what happens. I will get look at this and look at that one. The better triangulation, which is this one, this is the better one, you can see that I got triangles which are broader compared to this worse triangulation where I got triangles which are more slim with very small angles. Here all the angles are quite common, quite the same, almost 60 degrees. This one is quite small. So slim triangles we don't like, and slim triangles are characterized by small angles. It has also a very big one, but it has small angles. Therefore, we will order the vector of angles by the small angles in the start, and we will compare the start angles, and we will look in the start angles for the bigger angles. The triangulation that will give me bigger angles as the starting angles will be the better one, because a triangulation that will create angles, will create triangles with angles with the smallest angles to be bigger, is the better one. Okay, so this will be the idea. Now we'll continue to see how the how do you call it, the vector of angles for the second option is worse in our examples that I just started. I made a very short explanation to explain you what will happen. So let's get some I don't know, let's go back a little bit. Oh my god, where did I went? Where am I? Not here. Good. Now this is the triangulation that is probably worse. Now let's again look at the angles and again and create the triangulation vector. I get here 100, and this is 30, this is 50. This is again of course the same, so 100, 30, and this is 50. Okay, so if I look at the vector of, let's call it t tag, vector of angles, and again it is ordered lexicograph for the starting with the lower and continue with the higher angles. I start with 30, 30, 50, 50, 100, 100. Now when I compare those two vectors of angles, I see that in the start I get bigger angles in that vector. Namely, that vector I can say, even though here this is smaller than that, I don't care. I start only and look only on the first angle which is different between the two, starting in the lower ones. So I can say that this one, this triangulation, has a better angle vectors than the angles vector of this triangulation. And as I said, the one with the better triangulation vector is considered a better triangulation. Just it to be clear, if I have a triangulation which is, I don't know, let's call it triangulation of something else, a of, I don't know, d something, that is like, I don't know, 30, 30, 60, 60, 100, 100 for example, and I have another one of, I don't know, q or x, which is again 30, 30, 60, and now I don't know, 70, 100, 100. Oh, this cannot be. Let's call it, yes, I don't know, 60, maybe 70, and I don't know, I'm not sure that this is a variable even, I don't know, maybe it's not a variable triangulation, but I don't care. So I start to see which triangulation is better. This and this the same, this and this the same, this and this the same, this and this not the same. This one is better because it is bigger. So I say that the triangulation of x is better than the triangulation of d, just because of this. Even though this one is smaller than that one, this one is the same, I don't care. I start from the start and look where in the vector those two vectors are differ in the value. The vector with the bigger starting angle is the better triangulation. Okay, so I I wish that the triangulation idea and the angle vector is more of understandable now. This way we can compare two triangulation and understand which triangulation is better. Thank you very much. This is part of explaining on the Looney triangulation and how can we get to a better triangulation with a more expression that is better. Thank you very much. If there are any mistakes or correction, please tell me, and that is it.